In software architecture, boundaries refer to the points where different components, modules, or layers of a software system interact with each other or with external systems. Boundaries define the limits of a system, and the interactions across boundaries are often the most critical and complex parts of a system. As Robert Martin perfectly put, software architecture is the art of drawing lines that I call boundaries. Those boundaries separate software elements from one another and restrict those on one side from knowing about those on the other. So, there are different types of boundaries in software architecture, including process boundaries, component boundaries, module boundaries, layer boundaries, and system boundaries. So, what are these boundaries and what are their significance in the software architecture? Let's see. The first category is of process boundaries. These boundaries separate different processes or services running on the same or different machines. Then we have component boundaries, the boundaries that separate the different components within a process or a service, often based on functional or logical groupings. Then we have module boundaries, the boundaries that separate different modules within a component, often based on the specific functionality that they provide. And then we have the layer boundaries, the boundaries that separate different layers of a software system, like presentation, business, logic, and data storage layers. And we have the system boundaries as well, the boundaries which define the overall scope of the system and separate it from the external environment, including other systems, users, and hardware devices. So, an effective boundary management also helps to improve the system reliability, security, and performance because it reduces the risk associated with the unexpected interactions or dependencies across different parts of the system. So, to understand the boundaries in a software architecture, we can consider the example of an online shopping application where the system is divided into different layers, like the presentation layer, the business logic layer, and the data storage layer. Each layer interacts with the other through the well-defined boundaries. This approach separates the system into different layers, each with its own specific responsibility and functionality. That's why we use the layered architecture or the N-tier architecture pattern in our software architecture. And these layers communicate with each other through well defined boundaries, which can be established using different techniques like APIs, web services, or message queues. For example, the presentation layer can communicate with the business logic layer through RESTful API, which exposes the necessary operations and data needed by the presentation layer. The business logic layer can then communicate with the data storage layer through a database driver or ORM, object relational mapping tool, which provides a way to retrieve or store data in the database. To manage the boundaries effectively, the system architecture can also use different architecture patterns like service oriented architecture, model view controller, microservices, and so on. And they can also use different design patterns as well, like dependency injection, inversion of control, and service locator. These patterns help to decouple the different layers and provide a flexible and maintainable architecture. So, overall, we can say that by properly managing the boundaries between the layers, the application can provide a better user experience, be more scalable and maintainable, and reduce the risk of unexpected interactions or dependencies between different parts of the system. So, in that way, the system becomes more reliable as well. A simple approach to draw the boundaries in software architecture is to first divide the system into components. Some of those can be your core business rules and can be the plugins that contain the functions that are necessary but are not directly related to the core business rule. And then we can draw the dependencies arrows between those components. But those arrows should be arranged to point from lower level details to higher level abstractions, very much like the dependency inversion principle or stable abstraction principles defined by Robert Martin. So that's how we generally design the boundaries in the software architecture. More about this we'll cover in the next part.